Problem 175, we're taking a look at a polynomial and taking a look at the remainder theorem. So first of all, let's just do part A. We want to figure out P of 5. So that means I'm going to take 5 and I'm going to substitute it everywhere where there is an X. So I'm going to have P of 5 is going to equal 5 cubed minus 3 times 5 squared minus 7 times 5 plus 9. 125 minus 75 minus 35 plus 9, so P of 5 is going to equal 24. The remainder theorem, if we take a look at that, says that anytime you do polynomial division and you're dividing by x minus c, the remainder is going to be P of c. So the example they give here is that if you take x minus 5, if that's what you're dividing by for this polynomial, the remainder is going to be the same thing as P of 5. So for this problem, since we're finding P of 5, if we take x minus 5 and we divide this polynomial by x minus 5, we should get a remainder of 24. So that's what problem B wants us to verify. So that's what we're going to go ahead and do. So I'll just move this off to the side for a minute. So I'm going to make my generic rectangle for polynomial division and use x minus 5. So I have an x cubed, which means I have an x squared up top, negative 5x squared here. They need to add up to negative 3x squared, so I have a 2x squared, which gives me a 2x, a positive 2x there, which is negative 10x here, adding up to negative 7x means I need to have a positive 3x. Up top is plus 3. And then I have a negative 15. Well, negative 15, I need to make it equal a positive 9. So I'm going to add another box off to the side. So when I add these two together, they equal that positive 9. And that's going to be 24. So I do get x squared plus 2x plus 3, and my remainder is 24 over x minus 5. So I've now verified it with the remainder theorem. Hope that helps.